Hello everyone. Today we're going to review the notes for our final exam in elementary algebra. That's MAT0028. We're going to review for the final exam by looking at the highlighted problems. And we've done most of the highlighted problems in this module. Remember, your final exam is going to be exactly like this practice exam that we're reviewing today. We'll begin with number 2, which asks us to evaluate the expression for the given values. If x is -2 and y is 3, we're finding the value of y minus x squared. Now for this problem, we will substitute the values of y and x into our expression. Everywhere y is, we will replace the letter y with 3. And everywhere x is, we'll replace the letter x with -2. That will give us, if instead of y minus x squared, -2, or y is equal to 3. So 3 minus, and in parentheses, -2 squared. Now I'm going to move to the right and looking at this problem. So 3 minus -2 squared. So first let's look at our parentheses, -2 squared. That means -2 times -2, or +4. So it becomes 3 minus 4. 3 minus 4. And 3 minus 4 gives us -1 as our solution. All right, let's look at number 3. Number 3 asks us to simplify this expression, and using brackets, we have the absolute value of 14 minus 7 plus 4 divided by 3 plus 2 times 5. So looking at our numerator, the absolute value of 14 minus 7, first we need to subtract. 14 minus 7 gives us 7. We'll keep our vertical lines around 7. The absolute value of 7, that's the distance that 0 is from, or that 7 is from 0 on the number line, and that's just 7 units. So the absolute value of 7 is 7. And also in the numerator, we have plus 4. So 7 plus 4 in our numerator gives us 11. Divided by, in the denominator, let's look at what we have here. 3 plus 2 times 5. Our order of operations tells us to multiply first. So 2 times 5 becomes 10 plus the 3. We'll make our denominator 13. 3 plus 10 gives us 13, and this is our answer. 11 divided by 13. And then let's look at number 6. So we're solving this equation with fractions. We have 2/3 x plus 4/3 equals -2/3. To solve this equation, we first want to bring our 4/3 to the right. The opposite of adding 4/3 is to subtract 4/3. We're going to subtract 4/3 from the left and the right sides of the equation. Our 4/3 will cancel on the left side of the equal sign, and we have left 2/3 x equals. Now on the right side of our equation, we have 2/3 minus 4/3. So -2 minus 4 gives us -6, and 3 in the denominator. We keep our denominator of 3. Now, -6 divided by 3 can be simplified further, right? That becomes, how many times does 3 go into 6? -2. And then we have 2/3 x on the left side of the equal sign. To solve this equation at this point, we take the reciprocal of 2/3. The reciprocal of 2/3 is 3/2. So 3/2. We flip that fraction. That allows us to cancel the 3/2 and the 2/3 with each other. We're left with X on the left side of the equal sign. And over here on the right side, we can cancel out the 2's. And what are we left with? -3 as our answer. All right, let's look at number 8. For number 8, you're asked to solve for the specified variable. So we're solving for C. Given this equation, A equals B plus B, C, D. Since we're solving for C, that means we want to leave C by itself on the right side of the equal sign. So we'll start with the variable B out here by itself. It's a positive B. The opposite would be to subtract both sides of this equation by B. That allows the B's to cancel, and we're left with B, C, D on the right side, and on the left side, A minus B. We'll write A minus B. We can't subtract B from A because we don't have the value for B. Next, remember we want C by itself, so we need to get rid of B and D. Right now we're multiplying B times C times D. The opposite would be for us to divide both sides of this equation by B and D. So we're going to divide everything on the left and everything on the right side of the equation by B and D. That way our B and D will cancel on the right side of the equation, leaving C. And on the left side, we have our solution. A minus B divided by BD. And that will be our answer. Now let's look at number 10. Find the original price of a pair of shoes if the sale price is $56 after you get a 20% discount. So if we purchased shoes and paid $56 after we got a discount, and the discount was 20%. Remember, you have to change this percent to a decimal. That becomes 0.20. Now, how do we get 0.20? We take that 20% and we divide by 100, or either move the decimal 2 places to the left. So 0.20. All right, so $56 is the amount we pay out the door, but we really want to know the original price. We don't know what the original price was. So to get that sale price of $56, we have to take the original price and then subtract the discount. The discount is going to be our 20% as a decimal, so 0.20, multiplied by the original price. So it'll be minus 0.20x. That's how we get our discount. So this formula that you want to look at here would be sale price equals original price minus the discount. All right, and we have our sale price given to us. We don't know the original price, so we put X for the original price. The discount, we get that by multiplying our percent off as a decimal times the original price, so 0.20x. Now you want to look at this x as being a 1x. So 1x minus 0.20x gives me 0.80x equals 56. And to solve this equation, we would divide both sides of the equation by 0.80. 0.80s will cancel on the right side of the equation, so x equals, and when we divide on the left side, 56 divided by 0.80 will get 70. And 70 is the answer to our question. That's our original price. Let's look at number 11. So number 11, you have 2 spaces you got to fill in. A junior one-day admission to an amusement park is $21. The admission is increased for the adults. And we're going to find how much of an increase is, that markup, how much did it go up, and we want the adult price. So to apply this, We want to use a similar formula to what we just used for problem number 10. The adult price of our ticket, to get the adult price, we're going to take the junior price, which is $21, and we're going to add that increase. Remember, the increase is 0.70 or 70% as a decimal. That becomes 0.70. It'll be 0.70 times the junior price. So 0.70 times 21. All right, and we want to solve this to figure out what the adult price would be, right? And we also need to know the markup. The markup is simply what is that 70% increase. All right, so let's go ahead and begin solving this problem. We got X. Since we don't know the adult price, we'll just use X equals 21 plus multiplying 0.70 times 21, you'll get 14.7. Now this is our markup, 14.7. That's how much of an increase you find. And in dollars and cents, that represents $14.70. So the price of the adult ticket, we add these two numbers together. That markup, 14.7 plus 21, will give us the adult ticket price, which is $35.70. And that's our adult price. All right, let's look at number 12. For problem number 12, you're asked to solve this inequality and then graph the solution, write the solution as a simplified inequality. All right, so let's look at our inequality that we're solving here. We have negative 3x plus 4 greater than or equal to 2, and in parentheses 4 minus x. So here on the right side of our inequality, we need to distribute. We're distributing 2 times both terms inside parentheses. So 2 times 4 would give us 8 minus 2 times x, which is 2x. Bring down our inequality symbol and all the terms on the right and the left side. So bring down our plus 4 and minus 3x on the left side of inequality. Next, we're going to solve by combining like terms. So see our x terms, we want to add 2x to both sides so we can move our x term to the left of the inequality. And then our 4, we want to subtract 4 from both sides of the inequality so we can bring our constants over to the right side of the inequality. The 4's will cancel on the left. Negative 3x plus 2x gives us negative 1x. Greater than or equal to 8 minus 4, which is just 4. All right, now we need to solve this inequality by getting rid of this negative 1 in front of the x. So we have to divide both sides of the inequality by negative 1. And remember, whenever you multiply or divide both sides of an inequality by a negative number, you have to reverse that symbol. So that symbol will be reversed from being greater than or equal to less than or equal to. X is left on the left side of the inequality. On the right side, 4 divided by negative 1 gives us negative 4. So here's our inequality. X less than or equal to negative 4. All right, and remember our symbol, whenever we have less than or equal to or greater than or equal to, we're going to be using brackets. So we're looking for a graph that has brackets and not parentheses. So we know it has to be between A and C. But which direction is our arrow pointing? See how our arrow is pointing to the left. So it would be letter A because we're shading everything to the left. Right, now let's look at number 14. So you have, in parentheses, negative 8a squared, b to the 7th power, and c And then all of this stuff is being raised to the second power, which means we're going to take each term individually and raise them to the second power. All right, so let's look at what happens here. So let me erase some of those lines so we can see what's going to happen here. So you have -8 raised to the second power, a squared raised to the second power, b to the 7th power raised to the second power, and then c raised to the second power. So each of those terms we're raising to the second power. -8 raised to the second power is just 64. A to the second power, and when we raise it to another second power, that becomes a to the 4th power. Remember, we adding the powers here. 2 plus 2 makes that a to the 4th power. And then b is already to the 7th power, but times the 2 will make that b to the 14th power. I said 2 plus 2 times 2 makes us a to the 4th power. And then 7 times 2 makes us b to the 14th power. C times the 2. This is just 1, a power of 1. So 1 times 2 will make that c to the second power. And this is our solution. 64, a to the 4th power, b to the 14th power, c to the second power. Now, when we look at number 15, we're dividing now. Remember that r by itself is the same thing as r to the 1st power. But what we want to do is go ahead and combine those powers in the denominator. Because they have the same base, we can just add their powers. So -3 minus 5 will make that r to the -8th power in the denominator. In the numerator, we have r to the 1st power. Now we're dividing two terms that have the same base, so we're going to subtract their powers. So 1 minus -8, our power in the denominator, will give us, remember, two negatives side by side becomes addition, r 1 plus 8, or to the 9th power. And this is our answer, r to the 9th power. Look at number 16. So we're writing this number in scientific notation. Remember, scientific notation means to have our decimal point in a spot where the digit in front of it is smaller than 10, but it has to be greater than 0. So it has to be a single digit, 1, 2, 3, 4, 5, 6, 7, 8, or 9. So we need to move this decimal point back here to where our digits are. How many spaces do we need to move it? 1, 2, 3, 4 spaces to the right. When we move our decimal point 4 spaces to the right, we're left at 1.7 times. We have to now multiply our exponent by the number of spaces that we move to the right. Since we move to the right 1, 2, 3, 4 spaces, and remember to take this term out of scientific notation, we're going to have to move to the left. That makes our power -4. Because when we go to take this term out of scientific notation, we're going to have to move to the left. So it's 1.7 times 10 to the -4th power, and that's scientific notation. Number 17, we have 6x squared minus 3y squared minus 3, and minus, in parentheses, 3x squared minus 3y squared minus 6. We got to remember to distribute here. Distribute this minus symbol. So our first term remains the same. 6x squared plus 3y squared minus 3. And now minus, we're distributing the minus sign here, minus 3x squared minus 3y squared plus 6. A negative times a negative makes that plus 6. We're looking to combine like terms at this point. So 3x squared or 6x squared minus 3x squared. So 6x squared minus 3x squared gives us 3x squared. We're done with the x squared terms. 3y squared minus 3y squared, that's just 0. And then negative 3 plus 6, that gives us plus 3, and this is our answer. 3x squared plus 3. All right, let's look at number 19. We're multiplying both these terms in parentheses. Remember, we got to distribute. So 4x plus 4 in the first set of parentheses, 5x minus 9. In the second set of parentheses, we're going to distribute 4x times both the terms in parentheses, and then 4 times both the terms in the right parentheses. 4x times 5x gives us 20x to the second power. 4x times minus 9 gives us negative 36x. And in the center, 4 times 5x gives us plus 20x. And the last term, 4 times minus 9 gives us negative 36. At this point, you want to combine like terms. We have our 20x squared, and there aren't any other x squared terms, so we'll just carry down 20x squared. Now, in the center, we have two terms so we can combine. Negative 36 plus 20x. We can combine those two terms. That gives us negative 16x. And then lastly, minus 36. This is our answer. All right, let's look at number 20. Now for number 20, you're dividing each of these terms by 2x. All right, that's how you want to look at this. I'm dividing each term in my numerator by 2x. So that's 4x to the 6th power divided by negative 2x. And then negative 12x to the 5th power divided by negative 2x. And then lastly, 16 divided by negative 2x. All right, when we divide each term by negative 2x, our first term, 4 divided by negative 2 gives us negative 2. And now with my x coordinate, remember that 2x in the denominator means that my power is 1, and we want to subtract the powers. All right, so x to the 6th minus x to the 1st power, that's 6 minus 1, or x to the 5th power. And then negative 12 divided by negative 2 gives us positive 6. Now x, look at our exponents. We have 5 in the numerator, minus 1 in the denominator. That gives us 5 minus 1 gives us 4. So x to the 4th power minus 16 divided by negative 2 gives us minus 8. Now here, this could be a little tricky. In the numerator, we have 16, but we don't have an x coordinate. It may be a good idea to go ahead and put x to the 0 power. Because when you look at this variable, right, our x, we're going to subtract 0 minus 1. And 0 minus 1 gives us what? Negative 1. But we can't have negative powers. In order to make this exponent positive, we have to move it to the denominator. Remember, that's the same as 1 over x. So that's what's going to happen here. We move that x to the denominator because it's a negative power, and we want it to be positive, so we move it to the denominator. You don't have to write the 1 there. So this will be our answer. Negative 2x to the 5th power plus 6x to the 4th power minus 8 over x. All right, let's look at number 21. We're factoring by grouping here. Now, when we say group, you just want to put together the terms that are next to each other. Start with the first two terms, grouping them together, and the last two terms. Now, when you group your terms, you then want to find the GCF. So what is our GCF of both sets of parentheses? Here, I have 3x squared in the first parentheses minus 2x. So what can I factor from both of these? I can factor out an x. If I factor x, I'm left with 3x minus 2 in parentheses. All right, so that first set of parentheses, we factored out an x. We have 3x minus 2 in parentheses. Now look at our second set of parentheses, negative 15x plus 10. What do we have in common that we can factor? We can factor out 5. But I'm noticing as I'm moving ahead, remember when we're factoring, that we want to have the same term in parentheses. It's a minus here, so we want this plus to eventually become a minus sign. That means we should factor out a negative. So we're going to factor from our second set of parentheses, negative 5. If we factor negative 5 from negative 15x, we're left with 3x. So what do I multiply negative 5 by to get negative 15x is 3x? Minus, now why is it minus? What do I multiply negative 5 by to get positive 10? I got to multiply by a negative. Remember, negative times a negative is what makes that positive. So our second factors are negative 5, we factored out, and in parentheses, 3x minus 2. When you see the same terms in parentheses, 3x minus 2, you know you factored correctly. So what is our answer? It's going to be the two factors that are outside, so x minus 5, and the factor that we share, 3x minus 2. This is our solution. 3x minus 2 and x minus 5. All right, let's look at number 22. 22, we're factoring again. We have 11x squared plus 50x plus 24. Now let's write this up here, because when we have a leading coefficient, we have to do a little bit more work. 11x squared plus 50x plus 24. First, you want to multiply together your leading coefficient and your constant. So 11 times 24. You need to multiply those two terms together. And when you multiply 11 times 24, you'll get 264. And we need to find two factors where when we multiply them, we get 264, but when we add them, we get 50. We want our middle term. The two factors that we get are 6 and 44. 6 times 44 gives us 264, but when we add 6 plus 44, we'll get 50. So these are the two factors we want to replace 50 with in the middle. So instead of 50x, we'll write our two factors. Plus 6x plus 44x. We'll bring down the terms that are outside of the middle term. So 11x squared stays in the front and 24 at the end. Now we want to continue by factoring with the grouping method. So we're going to group together our first two terms and group together our last two terms. Find our GCF. So 11x squared plus 6x, we can factor x from both these terms. When we factor x from 11x squared plus 6x, we're left with 11 plus 6, or 11x plus 6. In our second set of parentheses, we're factoring, trying to find the GCF between 44x and 24. We can factor 4 from both those terms. When we factor 4 from 44x plus 24, we're left with 11x plus 6 in parentheses again. All right, we have the same factor, so we know we factored that correctly, and that's one of our solutions. So 11x plus 6 is one of our solutions. The other is going to be the outside term, so x plus 4. This is our answer, 11x plus 6 and x plus 4. Now let's look at number 23. We're factoring again, but we notice only two terms, and they're perfect squares. This is 5x squared. 5 times 5 gives us 25, and of course, x times x gives us x squared. And 16 is a perfect square because 4 times 4 gives us 16. So we factor this special difference of perfect squares as adding the two factors and then subtracting the two factors. So 5x plus 4 and 5x minus 4. That's our answer. All right, let's look at number 24. Now we're asked to solve this equation. So we'll actually be factoring, but then when we get our two factors, we're going to set up equations in order to get the solution. The first thing we need to do is, if our equation is not set equal to 0, we need to make it equal to 0 by moving any terms that are to the right over to the left side. This is a positive 32, so we need to subtract 32 from both sides of the equation. When we subtract 32 from both sides of the equation, we're left with x squared minus 4x minus 32 on the left side of the equal sign. On the right side, we have 0. Now we need to factor. So x squared minus 4x minus 32, we need to find two numbers. When we multiply them, we get negative 32, but when we add them, we get negative 4. So of course our x squared will be factored as x times x. But when we look at numbers that multiply together to give us negative 32, but add to give us negative 4, we're going to use minus 8 and positive 4 equals 0. So negative 8 times 4 gives us negative 32, but when we add these two terms, we'll get negative 4. Now we have to set each of these factors equal to 0 to get our solution. So x minus 8 equals 0, or x plus 4 equals 0. We're going to solve each of these equations. So x minus 8 equals 0, we solve by adding 8 to both sides. We'll get x equals 8, or subtract 4 here, x equals negative 4. So these are our two solutions, 8 or negative 4. All right, let's look at number 25. Now we need to factor in the numerator and factor in the denominator here. So we find two numbers where when we multiply them, we get 45, and when we add them, we get negative 14. And that'll be 9 and 5. So x minus 9 and x minus 5 will factor the numerator. In the denominator, two numbers that multiply together to give us negative 5, but when we add them, we get negative 4. That'll be x minus 5 and x plus 1. See how we have x minus 5 in the numerator and x minus 5 in the denominator? We can cancel those terms, leaving x minus 9 in the numerator and x plus 1 in the denominator. This is our answer. All right, let's look at number 26. We're finding this quotient. Now remember, when you're dividing by a fraction, it's the same as multiplying by its reciprocal. So we're going to keep the first fraction the same. It remains x squared plus 9x plus 14 divided by x minus 5. And then we change our operation. So remember that keep, change, flip. We want to change our operation from division to multiplication. So we change our operation to multiplication. And then we're going to flip the fraction on the right, meaning all the terms in the denominator we move to the numerator. All the terms in the numerator we move to the denominator. So that x minus 5 moves to the numerator, divided by x squared minus 7x minus 18. Now we want to solve this by factoring. All right, so we need to factor the terms that have trinomials. So x squared plus 9x plus 14, two terms. Well, when we multiply them, we get 14, but when we add them, we get 9. And that'll be 7 and 2. So x plus 7 and x plus 2 for our numerator. In the denominator, we have x squared minus 7x minus 18. We need two numbers. When we multiply them, we get negative 18, but when we add them, we get minus 7. And those factors that we're looking for number 26 in the denominator, we'll get x minus 9 and x plus 2. Now we'll cancel any like terms. So that x minus 5 and x minus 5 will cancel. The x plus 2 in the upper left hand and x plus 2 in the denominator will cancel. And what we're left with in the numerator is x plus 7 right here. And in the denominator, x minus 9, x plus 7. I wrote x plus 9, but it should be x plus 7 in the numerator. And x minus 9 in the denominator. This is our answer. All right, let's look at number 27. We have 4 divided by x plus 5 divided by 8x squared. Now remember, you can't add or subtract any fractions unless they have the same denominator. So we have to get the common denominator. I have 8x squared and x. Now I can multiply this x times 8x and make it equivalent to 8x squared. That's what we have to do. We want both of our denominators to become 8x squared. Now our 5 over 8x squared, we already have the denominator that we need. So we'll leave that 5 in the numerator. However, to change 4 over x to having a denominator of 8x squared, we have to multiply it by 8x. 8x squared is what we want. We have to multiply x times 8x. Therefore, we also must multiply the numerator times 8x. So 4 times 8x gives us 32x in the numerator. All right, let's go ahead and keep our denominator of 8x squared. And in the numerator, we have 32x plus 5. This is our answer. All right, let's look at number 28. We're simplifying this radical. We have the square root of 20m to the 7th power. Now, when you're looking at these perfect squares, you're really just, or these square roots, you're looking for the perfect squared number, the largest one that can be divided into the integer 20, and that's 4. 4 times 5 gives us 20. 4 is a perfect square, so we can find the square root of 4 and remove that from underneath the square root. Now, m to the 7th, we want to find the highest set of 2. So we really just want to divide this power by 2. What's the greatest set of 2's that I can take from m to the 7th? I could take 6 of them out, right? I could take m to the 6th power because 6 is the power of 2. When I take away 6 from the 7, I'm left with just 1 underneath. All right, now m to the 6th power, I can take the square root of that because that's 3 sets of 2. So my square root of 4 is moved outside. That becomes 2 outside of the square root. And m to the 6th, when we take the square root of m to the 6th, how many sets of 2 is in 6? That's m to the 3rd power. So these two terms we moved outside. What's left underneath the square root is 5 and m. This is our answer. 2m cubed times the square root of 5m. Now looking at number 29, we have 5 outside of the parenthesis, or out of the square root. And 64 is a perfect square number. The square root of 64 is 8. So we're just going to multiply 5 times 8 to get our answer of 40. All right, I'm going to stop the video here and then we'll pick up with the last few problems, 30, moving on in the next video.